Welcome to Intro Econometrics. I'm Dr. Dangerous Dave, and this is a look at econometric data. The names of most subjects in economics tell you what they're about. The name econometrics tells you what it does. It measures economic things. In the physical world, we measure some things directly. The length of a day, the weight of a watermelon, the height of a person. Other things we measure indirectly. The length of a day on a distant planet can be estimated from astronomical observations. The height of a tree can be estimated from the length of its shadow at noon. The weight of a ship can be estimated from the amount of water it displaces. Similarly, some economic things can be measured directly. The number of people in a town, the amount of money in a bank, the price of a school bus. Most other economic things are really hard to measure directly, but we're typically satisfied with statistical estimates of them. Examples are average wages, the range of household incomes, or the annual change in spending for schools. And many economic things reflect a complicated interaction between other economic things. How much do cigarette sales decrease when the tax on them increases? How much does it cost to increase breast cancer survival by 1%? How much does a bachelor's degree increase lifetime earnings? When we collect economic things with a purpose, we call them economic data. An apple could be agricultural data if we write down which tree it came from, for example, or graffiti could be sociological data if we write down the date and location, for example. Any economic things recorded for a purpose are economic data. So we were talking about three tiers of economic data which are produced in three distinct ways: direct measurement, statistical inference, regression. Statistical inference is analysis using statistics. Any conclusion we draw from average wages, for example. Regression finds the mathematical relationship between different data, the effect of taxes on cigarette consumption, for example. Each depends on the previous. Statistical inference needs measurements, regression needs statistics. Suppose that what you're measuring is a random variable. What does that mean? It's an important question. The kinds of tools we use in econometrics depends on the extent to which our variables are random. So what do we mean by a random variable? We mean we're very careful to collect it in a way that no one measurement can influence another. For example, if we have a way to pick people completely at random and then count the money that each one of them is carrying, that is a random variable. Suppose that instead of counting their money, we ask each individual in a group of people how much money they have where everyone else can hear. As we go along, the answers may be influenced by what others have said. That is not a random variable. We will use the term random variable a lot in our discussions of probability statistics and econometrics. We'll refine that definition further in the section on random variables, but remember this definition for now. A variable is random if one measurement is not influenced by any other measurement. This is one of the many terms we use that may have some other meaning when people use it in general conversation, but in our vocabulary, it has a very specific meaning. There are various types of data used in econometrics, the three most common being cross-sectional, time series, and panel data. See the discussion of econometric data types. Ceteris paribus, or ceteris paribus in Latin, is a term you hear often in economics. It means all other things being equal. Take a look at the section on ceteris paribus and endogeneity. Thanks.